210.12 arc fault circuit interrupter protection B dwelling unit bedrooms. All 120-volt single-phase, 15 and 20 amp branch circuit supplying outlets installed in dwelling unit bedrooms shall be protected by a listed arc fault circuit interrupter or AFCI combination type installed to provide protection of the branch circuit. Fine print note No. 1 for information on types of arc fault circuit interrupters. See UL 1699-1999 standard for arc fault circuit interrupters. Fine print note No. 2C 760.21 and 760.41 for circuit supplying fire detection and warning equipment. Let's break down each part of this requirement. Firstly, it specifically addresses arc fault circuit interrupter protection, commonly known as AFCI protection. Secondly, the location in question is dwelling unit bedrooms. Thirdly, the specific electrical systems affected are all 120-volt, single-phase, 15 and 20 amp branch circuits. Fourthly, these circuits must supply outlets installed in dwelling unit bedrooms. Fifthly, protection is mandated through a listed arc fault circuit interrupter or AFCI. Sixthly, the AFCI must be a combination type. Seventhly, the AFCI must be installed to provide protection of the branch circuit. Let's begin with the basics. An arc fault circuit interrupter is a device designed to detect electrical arcs, which are dangerous unintended electrical discharges. These arcs can occur for various reasons such as damaged wiring, loose connections, or faulty appliances. AFCIs are designed to quickly de-energize the circuit when an arc is detected, thereby preventing electrical fires. The National Electrical Code, or NEC, is a comprehensive set of standards and guidelines for safe electrical installations. It is updated every 3 years to reflect the latest advancements in electrical technology and safety practices. Section 210.12 of the NEC specifically addresses arc fault circuit interrupter protection. This section outlines where AFCIs are required in dwelling units to minimize the risk of electrical fires. Subsection B focuses specifically on bedrooms within dwelling units. Bedrooms are considered high-risk areas because people are often asleep and less likely to detect a developing electrical fire. The NEC mandates AFCI protection in these areas to provide an extra layer of safety. The rule applies to all 120-volt, single-phase, 15 and 20 amp branch circuits. These are the most common types of circuits found in residential wiring. They supply power to general use outlets, lighting fixtures, and small appliances. The specific mention of 120 volts is important because it distinguishes these circuits from higher voltage systems that may be present in a dwelling unit. Single phase refers to the type of electrical power being supplied. In most residential settings in North America, single phase power is the standard. The 15 and 20 amp ratings refer to the maximum current the circuit is designed to carry. These are common ratings for general-purpose circuits in a home. The NEC stipulates that the branch circuit supplying outlets installed in dwelling unit bedrooms must be protected by an AFCI. This means that all the electrical outlets in the bedroom, including those for lamps, electronics, and other devices, must be on circuits protected by AFCIs. It's crucial to understand that this requirement applies to all outlets in the bedroom, not just some of them. The AFCI must be a listed device. This means that it has been tested and certified by a recognized testing laboratory such as Underwriters Laboratories, or all, to meet specific safety standards. The listing ensures that the AFCI performs reliably and provides the intended level of protection. The NEC requires a combination type AFCI. This type of AFCI provides protection against both series and parallel arcs. A series arc occurs when there is a break in a single wire, while a parallel arc occurs when there is a short circuit between two wires. Combination AFCIs offer the most comprehensive protection against both types of arc faults. The AFCI must be installed to provide protection of the branch circuit. This means that it must be installed at the beginning of the circuit, typically in the electrical panel. This ensures that the entire circuit, including all the wiring and outlets, is protected against arc faults. The AFCI acts as a circuit breaker, interrupting the flow of electricity when an arc is detected. The fine print notes, or FPNs, provide additional information and guidance related to the code requirement. They are not mandatory requirements themselves, but can be helpful in understanding the intent and application of the code. Fine print note now 1 refers to UL 1699-1999 standard for arc fault circuit interrupters. This standard provides detailed information on the different types of AFCIs, their performance requirements, and testing procedures. It is a valuable resource for understanding the technical aspects of AFCIs. Fine print note No. 2 refers to sections 760.21 and 760.41 of the NEC, which deal with circuits supplying fire detection and warning equipment. These sections provide specific requirements for the wiring and protection of fire alarm systems. The reference to these sections highlights the importance of ensuring that fire detection equipment is properly installed and protected. To summarize, the NEC 2008 proposed change to 210.12b mandates that all 120-volt, single-phase, 15 and 20 amp branch circuits supplying outlets in dwelling unit bedrooms be protected by a listed combination type AFCI. This requirement is intended to reduce the risk of electrical fires in bedrooms by providing protection against arc faults. The fine print notes provide additional information and guidance on AFCIs and related fire safety systems. It's important for electrical contractors, inspectors, and homeowners to understand and comply with these requirements to ensure electrical safety. Now let's delve a little deeper into the practical implications of this code requirement. Firstly, when installing or upgrading electrical systems in dwelling unit bedrooms, it is crucial to ensure that all 120-volt, single-phase, 15 and 20 amp branch circuits are protected by combination type AFCIs. Secondly, this includes circuits that supply general use outlets, lighting fixtures, and any other electrical devices in the bedroom. Thirdly, the AFCI should be installed in the electrical panel at the beginning of the circuit to provide comprehensive protection. Fourthly, it's essential to use only listed AFCIs that have been tested and certified by a recognized testing laboratory. Fifthly, when replacing existing circuit breakers with AFCIs, make sure to properly identify and label the circuits to avoid confusion. Sixthly, homeowners should be educated about the purpose and function of AFCIs, as well as the importance of not tampering with or bypassing them. Seventhly, regular inspection of electrical systems, including AFCIs, is recommended to ensure they are functioning properly. Eighthly, if an AFCI trips frequently, it may indicate an underlying electrical problem that needs to be addressed by a qualified electrician. Now let's talk about testing AFCIs. AFCIs are designed with a test button that simulates an arc fault. Regularly testing AFCIs is a good safety practice to ensure they are functioning correctly. Here is how to test them. Firstly, locate the test button on the AFCI. It is usually labeled with the word test. Secondly, press and hold the test button. Thirdly, the AFCI should trip, interrupting the circuit and cutting off power to the outlets it protects. Fourthly, if the AFCI does not trip when the test button is pressed, it may be defective and should be replaced by a qualified electrician. Fifthly, after testing, reset the AFCI by moving the switch to the off position and then back to the on position. Sixthly, if the AFCI trips immediately after being reset, it may indicate a persistent arc fault or other electrical problem. Seventhly, in such cases, it's important to have the electrical system inspected by a qualified electrician. Let's address some common misconceptions about AFCIs. Firstly, some people mistakenly believe that AFCIs are only required in new construction. Secondly, while the NEC may have specific requirements for new construction, it's generally a good practice to install AFCIs in existing homes as well, especially in bedrooms. Thirdly, another misconception is that AFCIs are the same as ground fault circuit interrupters, or GFCIs. Fourthly, while both devices provide important safety functions, they are designed to protect against different types of electrical hazards. Fifthly, AFCIs protect against arc faults, while GFCIs protect against ground faults, which occur when electricity leaks to ground. Sixthly, some people may think that AFCIs are a substitute for proper wiring and electrical maintenance. Seventhly, however, AFCIs are a supplementary safety device and should not be relied upon to compensate for faulty wiring or other electrical problems. Eighthly, regular electrical inspections and maintenance are still essential for ensuring electrical safety. It is also important to understand the limitations of AFCIs. Firstly, while AFCIs are effective at detecting and interrupting many types of arc faults, they may not be able to detect all arc faults. Secondly, for example, some low-energy arc faults may not generate enough current to trip the AFCI. Thirdly, also, AFCIs may not protect against arc faults that occur outside of the branch circuit they are protecting, such as in appliances or extension cords. Fourthly, it's important to use properly rated and maintained appliances and extension cords to minimize the risk of arc faults. Let's talk about coordination with other safety devices. AFCIs should be coordinated with other safety devices such as smoke detectors and carbon monoxide detectors to provide a comprehensive safety system in the home. Smoke detectors provide early warning of a fire, while carbon monoxide detectors alert occupants to the presence of dangerous levels of carbon monoxide. AFCIs can help prevent electrical fires from starting in the first place. Now let's consider the economic impact of AFCIs. Firstly, while AFCIs may add to the initial cost of electrical installations, they can save lives and prevent costly property damage from electrical fires. Secondly, the long-term benefits of AFCIs far outweigh the initial cost. Thirdly, also, insurance companies may offer discounts to homeowners who have AFCIs installed in their homes. Furthermore, the installation of AFCIs can increase the value of our home as it demonstrates a commitment to safety. Let's talk about future trends. The technology behind AFCIs is constantly evolving, with new and improved devices being developed. Future trends in AFCI technology may include improved arc fault detection algorithms, enhanced immunity to nuisance tripping, and integration with smart home systems. As AFCI technology advances, it is likely that the NEC will continue to expand the requirements for AFCI protection in dwelling units. It is important to stay informed about the latest developments in AFCI technology and code requirements to ensure electrical safety. In conclusion, arc fault circuit interrupter protection is an essential safety measure for preventing electrical fires in dwelling unit bedrooms. The NEC 2008 proposed change to 210.12b mandates the use of listed combination type AFCIs on all 120-volt, single-phase, 15 and 20 amp branch circuits supplying outlets in bedrooms. This requirement is intended to reduce the risk of electrical fires and save lives. It's crucial for electrical contractors, inspectors, and homeowners to understand and comply with these requirements to ensure electrical safety. Regularly testing AFCIs, addressing any electrical problems promptly, and coordinating with other safety devices can further enhance electrical safety in the home. By staying informed about the latest advancements in AFCI technology and code requirements, we can continue to improve electrical safety and prevent electrical fires. Remember that electrical work can be dangerous. Always consult with a qualified electrician for any electrical installations or repairs. These devices are critical for fire prevention and should not be ignored. It's also important to choose a reliable brand of AFCI and to follow the manufacturer's instructions for installation and testing. If you are not comfortable working with electricity, it is always best to hire a qualified electrician to install or replace AFCIs. They have the knowledge and experience to do the job safely and correctly. In addition to bedrooms, the NEC also requires AFCI protection in other areas of the home, such as family rooms, dining rooms, living rooms, parlors, libraries, dens, sunrooms, recreation rooms, closets, hallways, and similar rooms or areas. The specific requirements may vary depending on the edition of the NEC that is in effect in your area. It is important to consult with a qualified electrician or electrical inspector to determine the specific AFCI requirements for your home. Also remember that AFCIs are not a substitute for proper wiring practices. It is essential to follow all applicable electrical codes and standards when installing or repairing electrical wiring. This includes using the correct wire size, making proper connections, and protecting wiring from damage. AFCIs are designed to detect and interrupt arc faults, but they cannot prevent them from occurring in the first place. Proper wiring practices are essential for minimizing the risk of arc faults and other electrical hazards. Furthermore, it is important to be aware of the signs of a potential arc fault. These signs may include flickering lights, unusual odors, or sparking outlets. If you notice any of these signs, it is important to investigate the cause and take corrective action. This may involve replacing a damaged outlet, tightening a loose connection, or repairing damaged wiring. If you are not comfortable performing these tasks yourself, it is best to hire a qualified electrician to do the work. Let's also discuss the different types of AFCIs that are available. Firstly, branch circuit AFCIs are designed to protect the entire branch circuit, including all of the outlets and devices connected to it. Secondly, outlet circuit AFCIs are designed to protect only the outlet where they are installed. Thirdly, combination AFCIs provide both branch circuit and outlet circuit protection. The NEC typically requires the use of combination AFCIs, as they provide the most comprehensive protection. There are also dual-function AFCIs that provide both AFCI and ground fault circuit interrupter, or GFCI, protection. These devices can be used in areas where both types of protection are required, such as bathrooms and kitchens. It is important to choose the correct type of AFCI for the application. Another consideration is the sensitivity of the AFCI. AFCIs are designed to trip when they detect an arc fault, but they can sometimes trip due to other causes, such as electrical noise or transient voltage surges. This is known as nuisance tripping. Some AFCIs are designed to be more resistant to nuisance tripping than others. It is important to choose an AFCI that is appropriate for the electrical environment in your home. Talk to a qualified electrician for recommendations. Also, it is essential to keep in mind that AFCIs have a limited lifespan. Like all electrical devices, AFCIs can wear out over time. It is recommended to replace AFCIs every 10 to 15 years, or sooner if they are tripping frequently. Replacing AFCIs is a relatively simple and inexpensive task that can help ensure the safety of your home. By understanding the NEC requirements for AFCI protection, the different types of AFCIs that are available, and the importance of proper installation and maintenance, you can help protect your home and family from the dangers of electrical fires. And again, if you are not comfortable working with electricity, it is always best to hire a qualified electrician to do the work.